Okay, how can you write an equation to represent the relationship between an independent variable and a dependent variable? Okay, so the independent variable in an equation is what's changing. Okay, and when the independent variable changes, the dependent variable is going to be affected by that change. Whatever happens with this variable is going to cause a change in the dependent variable. The dependent variable depends on the independent variable. Okay, you can think about this sentence to help you. The independent variable causes a change in the dependent variable. It isn't possible that the dependent variable could cause a change in the independent variable. Let's look at what that means. Okay, Kelly downloads songs from iTunes. Each song is $1.99. The total she spends T is equal to the number of songs she buys times $1.99. Okay, so one of these is the independent variable. It's going to change. And when it changes, it's going to cause a change in the dependent variable. Okay, the value of the dependent variable depends on the independent variable. Okay, so we have two variables. One represents the total cost, and one represents the number of songs she buys. Okay, so if Kelly bought two songs, okay, the total cost is going to change. It's $1.99 for one. If she bought two songs, it's going to be $3.98. Okay, if she bought three songs, it's going to be $5.97. Okay, so when the songs changes, the number of songs she purchased changes, it causes the total she spends to change. So the independent variable is S, the number of songs she buys. The dependent variable is T. Okay, so let's think about this. The value of the dependent variable, which is the total cost, depends on how many songs she buys. Let's look at our sentence down here. Okay, the number of songs she buys was the independent variable. It causes a change in the total cost. It's not possible that the total cost could cause a change in the number of songs she buys. Okay, so think about which variable is causing the other one to change. Let's look at another example. Sam rides the bus almost every day. He pays $2.50 for each bus ride. Find the total cost for our rides. Okay, so it's $2.50 for each ride. We're going to multiply that by the number of rides to get the total cost. Okay, so let's think. One of these, the independent variable. Remember, the independent variable is going to change. And when that changes, it's going to affect the other variable. Okay, so let's look at that. We have two variables, R and C. Okay, so Sam rides the bus almost every day. So if he took one ride, $2.50 times 1, it would cost him $2.50. If we change that variable, let's say he took two rides, that's going to change the total cost. The total cost depends on how many rides he takes. Okay, so the total cost is the dependent variable. The independent variable always changes, or the independent variable can change depending on what you substitute in there, and it causes a change in your other variable. Okay, so the number of rides Sam takes changes, and when that changes, it causes the total cost to change. Let's think about this sentence. Okay, the number of rides causes a change in the total cost. The total cost doesn't cause a change in the number of rides. Okay, you don't know the total cost until you know the number of rides. So the independent variable changes, and the dependent variable is affected by that change. Okay, the value of the dependent variable depends on the value of the independent variable. So always think about that when you're trying to identify the variables. One of them's changing, and when that changes, it causes the other one to change. The independent variable is independent, okay? It causes a change in the other one. The value of the dependent variable depends on what the independent